So a couple of the basic features of the system, obviously it's an 8 kilowatt hybrid inverter. The 8K, which is roughly 33, 34 amps, is when the power is out and you're just feeding from the battery only. Keep in mind that a solar system, the reason why current solar systems, when the power goes out, the home power still goes down, is solar is not a stable enough power source to really run an inverter effectively and generate AC. The battery acts as the buffer. So obviously in our system, when the power goes out, the solar is still keeping the battery charged and the battery is still running the inverter, so your home stays up. But when you're on solar only, you're getting 8 kW or about 33 to 34 amps. Now, ironically, the average home usage in the United States is only about 5 kilowatts. If you go look at like a Tesla Powerwall, theirs is a 5K system, and that's why. That truly is the average. Now, that doesn't account for spikes. Our inverter can spike up to 16K, but it's for a really brief period of time. You know, if you've got a fridge that's going to kick on, an AC that's going to kick on, it can handle those spikes for a brief period of time. But 8K is really the number you want to focus on. You want to try to keep your load calcs under 8K on whatever box you're trying to provide. Now, the system does allow a full 90 amp pass through from the grid. So while you're on grid power, full 90 amps from the grid pass through this unit into your wall. So if you do have spikes of 12K, 14K, 15K, the grid is actually your backup at that point. The grid will take over the spike while your system is offsetting everything 8K and under. I've done several analysis on my own home. I think in the month of August, there were 5 times when if this system's not installed yet, it's going into 2 weeks. But had I had the system installed, there would have been 5 times in August, or for a brief period of time, I would have ended up using the grid because I went over the 8K. And outside of August, it's only happened 5 other times the whole year. And that's primarily because of air conditioning kicking on.
Makes sense.
So as you're scrolling down, this is kind of a down and dirty of how the system looks on the inside. Just to kind of briefly go over everything on the front, you're going to have indicator lights. And really, it's just normal and alarm. There's just a green light and a red light. And really, that's just to help you with your customers if you're the one selling this to the end user to troubleshoot. You know, you don't want them opening it up and getting inside and trying to do a bunch of stuff with it. If the systems has the normal green light on and they're not getting power, then their battery's probably dead or something else is going on. If the red alarm is on, that's where we need to diagnose the problem and go into the fault codes and figure out what's going on. And we'll talk about how to do that in just a moment. Once you get to the inside of the unit, well, first we'll go over here to the side. On the side, there's a DC disconnect and an on-off button that turns off the whole inverter. Depending on code and where you are, you may have to wire this on-off button out to an outside wall where a fireman can hit a button and shut it off. But in some jurisdictions, that's required. In most jurisdictions, you just have to have a placard on the outside of the home with the map showing where in the home the unit is, and here's the on-off button. The current NEC, the current National Electric Code, only requires what we have here. But I know in my jurisdiction, the inspector is making me wire a button to the outside of the home, and you just basically tie into this button with a simple communications wire, run that out to an outside wall. Other than that, inside the unit, you have your battery connections. So these are oversized battery lugs. We recommend 6-gauge wire. These are your communication ports. There's actually 2 sets of them. One, the set on the bottom is used to parallel inverters together. So if you wanted more than 8K, you can actually connect up to 6 of these together if you really want to go overboard. You put one of them in the control mode, and the others basically act as subservient to it. They just serve it. But that one has to be the brain and the main communicator, and that's done by means of these communication ports down here at the bottom.
So like a business application, or municipality.
Or just larger homes.
Okay.
Yeah, several of the homes we've done, like down in southern Utah, northern Arizona, where they're running, multiple 5-ton air conditioning systems. We just met with one of the installers that's doing a bunch of these down down in that area, and his average home uses 3 inverters and 6 batteries. And you can set those up. So if you had 3 inverters all paralleled up, that means your pass-through is now 270 amps. So you don't have to have a separate critical loads panel in a whole house. Just run your loads into this and run your whole house, because you're getting, so much energy. You're getting 270 amps pass-through. And then when the grid goes down, you're still getting right at 100 amps. So you're still getting 24K backed up with the batteries and the solar. So that's why you had multiple communication ports. The batteries, each battery or each inverter can facilitate up to 3 batteries. If you're going to go more than that, then you're outside of what the manufacturer recommends per inverter. Still can be done. We'll just want to walk you through it. But 3 batteries is 40 kilowatt hours, 40.5 kilowatt hours. And unless you're without sun for an extended period of time, we're talking 2-3 days, you're probably going to be just fine. But again, if you're in an area that's like that, if you're installing up in Alaska and it's winter or something, that's where you'd have the backup generator to keep the batteries charged. As you're coming across here, these green inputs right here, this is where your line, your load, and then your generator in and out can all be connected, okay? And then your ground, I guess I made a big deal out of that. The unit does need to be grounded, or it'll throw a ground fault. And then this Wi-Fi dongle down here is how the device communicates. So in order to program the device, you need to be in close proximity. You do a local Wi-Fi connection. There's a little, and we'll talk through this when we get further in the manual, but there's a QR code right on the dongle that is specific to this unit that will help you connect. And then you can walk through a series of screens, which will go over the manual, and set the unit up. You can also connect this to your Wi-Fi in your home and then monitor it remotely. You cannot change the settings remotely. So that's one thing that you just need to be aware of. You can see what's going on remotely, but you can't change the settings unless you're physically there doing a local connection. So just to go over a real quick basic install, you can have up to 3 sources of power, like we talked about, coming in, comes into your unit, into your panel of your home, and then out to your home. Installation location. This is important, especially if you're going into a market where there's a lot of heat. These units are designed to be installed in a temperature-controlled environment. This has to do with the UL 9540 rating that we have on them. UL does not allow a high temperature buildup during maximum charge of the battery. In order to meet those parameters, this unit needs to be installed in an area that stays 86 degrees or less. So when if you're in a real warm climate, that probably means not the garage. It definitely means not the outside of the house. Now, there is a Gen 2 that we're working on that's probably 6 to 10 months away that will be air conditioned and heated, that is meant to be more of an exterior install, but that's a ways off. So just be aware that we do need to have it climate controlled for maximum life of the unit and to make sure you're meeting all the UL requirements.
So if these are installed in a basement, right, that should be more than...
Correct. In fact, in my home, we're putting it right in the utility room, which is in our basement. Right, it's that little unfinished room off in the corner of the basement that's got the water heater and everything else in it. That's where we're putting ours. I was fortunate enough to know we were putting this in before we built the house. So I kind of put everything there already. So the panels are already there, the wires are already run, the conduits are already there. But it's still not an overly difficult install as long as you have a blank wall somewhere close to your panel. It's pretty simple. As far as panels, we have included this chart. We get a lot of questions about how much solar can I put into this unit. The guidelines from the manufacturer and from UL are going to say no more than 36 panels. They do that for a voltage safety. They're also going to tell you no more than 10.4 watts. And that already has a buffer built in. The system accepts 8 watts or 8 kilowatts. So a 10K system, 10.4 kilowatt system is already oversized for the 8 kilowatt that this thing can accept in solar. So that's kind of the maximum number you're looking for. But the most important number out of all of this is the voltage that you're bringing in. So if you look at this, we've included this chart that shows you how to program each string or how to wire each string in your solar array. So you can have up to 4 strings of panels, but you need to try to keep them balanced. And this chart helps you do that. So for example, if you're putting 10 panels on your roof, so roughly a 3.5K system, then you would only use one of the MPPT charge controllers, and you would put 5 of those panels on each string. Okay, that's just how to best maximize the system, because 1, you have to keep them balanced. 2, you can't put more than 9 on a string because you're going to go over voltage. So if you look down here, it says 500 VOC max. Every solar panel on the back has a VOC, your open circuit voltage that panel produces. Most of them are between 41 and 49 volts of open current. And so you can tell if you were to go to 10, you'd be pushing that 500 volts open, and you don't want to get close to that. The best usage, the most efficient way the charger works is with a maximum of 425 watts or volts. So you might want to take a note that if you're designing these systems, to try to shoot for that 350 to 425 volts without going over, and that's per string. So if you go back to the example of most of these panels being 300 to 350 watts, 350 watts times 9 panels, should be able to do that in my head, is what, 31, right? 315 volts. So that's right in that sweet spot for the voltage to make sure the MPPT is working efficiently. You can go as low as 125. So 125 is where the MPPT starts to kick in and starts to function efficiently. So you really don't want to ever go less than 5 panels. Okay. And that just kind of shows you where you wire them and how everything would go together.
And that's if you're using panels, because you could use these units without panels, just having it.
Correct. You could just have the power from the home going through it, storing extra energy, and just have it be a whole home backup system.
Got you.
Yeah.
But if you have panels just on it, you want to have at least 5.
Correct. Minimum of 5. Or a minimum of 125 volts. So I guess if you had some really strong panels, if I take 40, so 125 divided by 40, you could probably get away with 3 panels if you had some good strong panels, but that means that you're not going to be able to have morning sun and evening sun. You're not going to have enough voltage coming in to make everything work. So I'll let you guys read all the stuff. We'll just kind of go down. This just shows you how the little wiring nuts work. The bottom of the unit, we do have weather resistant cable glands. Clearly those aren't as applicable to this unit because we're currently doing an inside install only, but our intent is to use this same configuration once we get the heating and air conditioning of the unit done for Gen 2. So really this is more of a future proof for the next iteration of the product because right now we don't advise installing this in an exterior application. Well, that's pretty straightforward. Okay, so when you install the system, you'll go down, you need to first of all download the SolarMan app. And so you do want to, once it's downloaded, this is a close-up of that Wi-Fi dongle. So you can see that little QR code there. That QR code will take you to the app to download it. And then there's a password in a really small type right there. You enter that password and now you're connected locally to the unit. Then you can go in, turn on your Wi-Fi adapter and program the unit to connect to your home Wi-Fi. That's not required for programming, but that's very nice to set up because then down the road, you can open the SolarMan app on your phone and see how's my inverter doing, what's my state of charge on the battery. You can also see the flow of power in and out of your home at that point as well. So by going through these screens, we won't go through all of them. There's about a million different scenarios you could set up. But by going through these screens, you can actually see the data that's going to be output either to the phone or to the app. So you have the solar data. This tells you what's coming in on each one of your 4 strings. It shows you what the current is, what your daily production has been for the last 24 hours, how much you've produced since you put the system in. Battery data will walk you through all the current statuses of the battery, whether it's charging or discharging. When we took this snapshot of our unit that's installed here, the battery was actually powering. That's why you see a negative 17 watts there. The battery actually had power being drawn to support the room, which I think we just had lights on at the time. And then the grid data, if you want to see what's coming in and passing through from the grid. And then the same thing for the inverter. And so anything you'd want to know about the system, both real time as well as 24 hours and historical, can all be seen through these screens. Then you can come down and we start going into the setting tabs. When we ship this to you, the battery settings are already set for the battery we ship with it. So you don't have to program anything here. It's already set for the battery to wake up the inverter. The ideal settings for the battery are already programmed, etc. But when you go to the next screen, this is where you're going to have to determine how you're going to use the inverter. Are you going to be selling to the grid in a net meter? Are you going to be zero export to load, which means, hey, the only thing we're doing is taking the power from the panel it's connected to, and it's only going to provide enough power to fill that panel? Or you could export to a CT sensor. And what that is for is to try to offset all the power that your home is using even upstream. So in my home, I have the main panel in my utility room that the power from the grid comes into. In that panel, I have all the heavy loads. So I have my air conditioner, 220 line to the garage, 220 line. I keep thinking one of these days I'm going to hit the lottery and buy a Tesla. So I have a 220 line to the garage to charge. I have, just those big loads are in that first panel. Then I have a 70 amp breaker that goes out that will go into the sanctuary system. And then from the sanctuary system, it will go into the second panel, which is everything else in my home. So what I would do when I set this up, I would set it on zero export to CT, because the system comes with some CT sensors, but I will put around that first main panel. And then what will happen, as long as the grid is running, the sanctuary will try to offset power in both directions. So when my AC is on, or if I'm using that 220 line in the garage, even though it's upstream, if you will, from the sanctuary, the CT sensor still senses that draw and it will send energy backwards to try to offset that. It won't send more than that's taking because you're not in a net zero, you're not in a net metered mode. Without a net meter agreement, you're not allowed to back sell to the grid. And that's what that CT sensor does. It only sells back to itself, okay? And then once that need is met, it will also then go forward to the panel that powers everything else in my home. So even though that air conditioner is not backed up by my sanctuary, most of the time my sanctuary will still be feeding power to it as long as the power's on. Now, as soon as the power goes off, the CT sensor stops seeing power flow and the unit will no longer send power backwards or upstream. That's required for UL 1741 for grid interactivity of a connected system. Now, it will only do what we call export to load. It will only feed to that secondary panel, which powers all the other loads in my home that aren't the big ones. So you can set it up to do any of those three or a combination of them. And then this just goes through all the different definitions of what the different settings mean. And then it's going to go through each one of the settings individually. So when you're in the grid, there's settings that you'd want to set up. Smart load is that third set of green connections, which can either be a generator in, but can also be a power out. So the smart load area enables you to set that up. There's some advanced functionality. Remember I talked about being able to control the time and when you're using time. That's what the grid peak shaving and grid peak power are all about. It also does allow you to turn the generator on during those times as well. If you happen to live in California and really get charged a lot of money during the peak time, it may be cheaper to fire up your generator, and this allows you to do that. The next page goes over all the fault codes. So if you do have an alarm going off and a customer calls, you can, through the app, you can see what fault code's going on, and you can then help to diagnose it. And we're going to have at least one, if not two, of our engineering team available to take those phone calls if you have anything like that going on, so they can help you diagnose it.
Excellent.
And then you go to the tech specs. This next section is what you are going to need to include in any application for a building permit. This is what your inspectors or your county, your city government are going to want to see. The model number is what they go look up in the database to certify that it's UL rated. So we have one for the battery, and we have the one for the inverter that goes on for a page and a half. And then the last page covers our warranty. So the warranty on this system works different from most of our products. We do include a 10-year warranty with this item. And that 10 years, just, especially if you're selling a customer that says, hey, we've never heard of Lion Energy, they're a newer company, what good's a 10-year warranty for a brand new company, right? And so what we have done is we've actually gone out and contracted an insurance company, and this is an insured warranty. So the 10-year warranty that comes with the unit, we're paying the premium for to the insurance company, so it's backed up and insured. There is a 25-year warranty that you can add, that you can purchase separately, that then extends this warranty up to 25 years. And again, that's through that same insurance company. And Fuquan, I don't know if I've sent you the most recent price list or not. If I haven't, I need to, because the warranty prices are on there now.
Okay, good.
I want to say it.
Okay.
Okay, then I'll send, as soon as we're done with the call, I'll shoot you a quick email with the updated price list, because has a warranty as a separate set of lines, so you can see what that cost is. And there's a little bit of difference from the 1 battery to the 2 battery to the 3 battery.
Okay.
It does go up a little bit with each one, but it's not crazy. I think the 1 battery, 1 inverter, 25-year warranty is $1,500.
Okay.
And that extends it to 25 years. And just in full disclosure, basically what that means is we're pretty much planning on replacing the inverter in that 25 years. Inverter is the one piece of equipment on here that may not last a full 25 years. And so really what we're doing is we're insuring against replacing that. Batteries are going to last 25 years without a problem. Batteries in this unit are lithium iron phosphate, same that we're using in the ME. Those batteries in the format that we're using here, which are the prismatic cells, are rated at 3,000 to 3,500 life cycles at full depth of discharge. The default on the system is to set it to 90%. At 90%, we guarantee 6,000 life cycles on those batteries. So that means it's roughly a 20-year battery being used every single day, down to only 10% left. In my own home, I'm going to change that to 80%. So I'm only going to charge it to 90% full. I'm only going to take it to 10%. And in doing that, you're going to double that again and have a 12,000 life cycle battery. So now you're talking a 35, 40-year battery by just going to 80% consumption. And the way our pricing works with the small, we want you to buy the system, and we're trying to incent you to add more batteries because we know it works more efficiently that way. So if you look, to add a second, third battery is pretty much a nominal fee on ours. And the whole goal behind that is so that you can have a 40.5 kilowatt, 40.5 kilowatt hour battery, program it to 80%, still give yourself well over 30 kilowatt hours, and now have a battery that's going to last you 30 to 40 years if you're using it every single day. As far as recycling, just to throw this in here, obviously you can't just go chuck these and take them to your local landfill or throw them in the garbage. There's a lot of lithium in there. The way our warranty program is going to work is if one of your customers, whoever does the install, we do require them to get a hold of us with one of our engineers to help us troubleshoot the device. Once we determine it's defective or there's a problem with it, we will send out a replacement, preferably to the installer, because they probably have the equipment to move a 300-pound battery around. but we can ship it right to the homeowner. The battery needs to be replaced, or the inverter, or whatever piece of equipment it is. The faulty piece of equipment comes off, goes right back in the exact same packaging. We shipped a new one to you in, and we contract with one of our freight carriers to bring it back to us. We'll troubleshoot it. We want to do our own investigation to try to improve for the future, and then we'll recycle the lithium and deal with that from this end. So our goal is to not have you have to worry about that. In the first few weeks of dealing with county and city inspectors trying to get building permits for folks, one of their big concerns is, hey, we don't want to be responsible for recycling all this lithium in our county landfill. What are you doing about that? Now you have my answer.
Right.
We're bringing it back, and Lion Energy is going to take care of it. So that was kind of a fast, down and dirty.
That was great.
What questions do you have? Anybody have any questions?
Yeah, yeah. Thanks for that. That was fantastic. I did read the manual, but you've kind of really clarified a lot of things for me. I guess in Bermuda, from Bermuda context, I see a lot of application for schools and more commercials, because a lot of the meter rooms are indoor. A lot of the older Bermuda houses have their meter rooms outside, and there's a lot of limestone, and it can get very hot during the summer. During the winter, not too much, because we're in the mid-Atlantic, but we have some competitive products like the Enphase, I think one called Sonics. And I just want to kind of first of all, have you heard of these? And
Yep.
How does the Lion Energy platform compare functionally and price-wise to these platforms?
When you're looking at a full battery system, an Enphase is probably one of the better ones out there that I'd compare us to. The biggest difference for us is when you get to the 3 battery system. If you're comparing our pricing on a 1 inverter, 1 battery, we're going to be a little cheaper than like an Enphase. But once you get to the 40.5 kilowatt hour battery, we're like half the price of what they would be to put a battery of that size in. The other thing that we do a little bit different than them is we are a hybrid inverter. So we're made to be off-grid, on-grid with generator charging capability. And I apologize, I don't know that Enphase product as well as I probably should, but my understanding is it's not a full hybrid inverter, that it won't do all the different modes with one unit. And that's kind of where we become a little bit different from them. Also, correct me if I'm wrong, isn't Enphase a micro-inverted AC-DC system?
I believe so. I haven't
Yeah.
done a lot. Yeah, I haven't done a lot of research on it.
Yeah.
I just know that that's a competitive product out there.
It is. And Enphase, what Enphase does is they require microinverters on the panels that microinvert the DC to AC. So it's AC coming into the system that's pre-inverted.
Mhm.
It costs you more money to do it that way, and it's less efficient to do it that way. We bring it all in straight DC to DC. So it's an easier install. You're literally just daisy chaining the panels together, bringing a wire down and plug it into the unit, and your
Gotcha, yeah.
solar's installed.
That's
You
right,
don't have
it
to
is.
mess with the microinverters. We also gain some efficiency. Usually on those microinverted systems, your efficiency is in the high 80% range, where we bring in straight DC to DC, then do all the inverting at one point at one time. We're at about a 96% efficiency. So you don't have as much loss in the conversion of your PV power to usable AC power with the DC to DC connection. So those would be the primary differences. So you can get more battery for less money, and it's an easier install, and then a higher efficiency on your energy conversion.
Awesome. Thank you.
Have you also done any kind of comparison between Solarcs?
So I have to be very careful from a legal standpoint when I talk about Solarc. Solarc has a lot of very substantially similar features to our unit, okay? In full disclosure, they're made from the same German chipset. We were developing them before them. They brought theirs to market before us. We did 2 additional years of testing after they hit the market with what was our unit. So we have a little bit of a legal thing going on there, which is why I have to be careful about what I say. Their unit does not allow 90 amp pass through from the grid. I think it's either 50 or 60 amp pass through from the grid. Their 12K unit is talking about 12K of solar. It does not allow 12, it's not a 12K inverter. Their inverter is still a 7.6K inverter. So our inverter is a little bit bigger at a full 8K. Our solar input is smaller. So their system is really designed first and foremost to be off-grid exclusively. They can do on-grid and net metering because they have that same chipset in there, but ours is more designed to be an all-around hybrid inverter. So there are a lot of similarities in our inverter is the short answer. They, however, do not manufacture batteries. Our primary business is energy storage. And so we do feel like we've perfected the battery. And so I think they primarily sell theirs with batteries they buy or they source from someone else, but they're not lithium iron phosphate. So when you plug a battery into a Solarc, your battery levels that you read out on the Solarc monitoring app are based on volts, amps, what's being used by the system. Basically, it's coulometer, just keeping track of what comes out and what goes in to those batteries. Ours are a full communication protocol. So we have an RJ45 plugged in, and the unit actually knows the true state of charge of the battery at all times, exactly where it is. And because of that, we have a 9540 rating, which depending on where you're selling this matters. You cannot sell into the state of California, Hawaii, Arizona, parts of Utah now. And I don't know about Eastern United States, but trust me, it's coming. UL 9540 is a big thing, and you can only get that. That rating only exists on an inverter and battery together with full communication and full controls to protect against thermal runaway, make sure the charging temperature stay in line. Basically, it's meant to where you're not going to cause a fire, you're not going to melt down the unit. And so when it comes to Solarc, the similarities really stop at the chipset and the inverter. Everything past that is where we start to diverge.
Great, great. Along that line of questioning, do you have, similar to what you have with the batteries, let's say the UT1300, a comparison of units, or is that something that's in production, like for a sales sheet comparison?
The UT1300s?
Yeah, I'm saying when you compare the different batteries that are out there with the Safari batteries, the Lion Energy batteries, is that
the
something
interesting thing when you start to go compare those, it's really interesting. We I think I told you when we first started talking that's our flagship product. We sell more of those unit wise and dollar wise right now than anything, although in less than 3 months the ME is catching it for the year very quickly, which is kind of scary. But the UT1300, the Safari batteries, are a lithium iron phosphate, which there are other lithium iron phosphate batteries out there, but we're really the only one of a major brand that's mass producing them with prismatic cell. So when you look at our competitors, like a Battleborn, like a Relion, like a Renogy, like some of those other batteries that are using lithium iron phosphate, they're all using cylindricals. Right. So the biggest difference there is first the weight. A Battleborn, which is probably the closest competitor that we get compared to all the time, it weighs 30% more than we do.
Yeah.
Actually, I think it's 50% more than we do because they weigh 36, 37 pounds,
Right.
and we're 24.
My question, I'm sorry, I should have said my question clear. So that comparison sheet that you have for the batteries, do you have a similar sheet for the Sanctuary,
this?
comparing the Enphase and,
Not yet. Our engineers are putting that together. It's really tough to do that because really the only unit that has the functionality of our inverter is the Solarc.
Mhm.
That's the only one that kind of works the same way.
Gotcha.
All the other inverters out there are either micro inverted or really made to be set up just for net metering. Even if you go to a SolarEdge storage, it still doesn't do the gen start and doesn't do the pass through and doesn't do a lot of the features that our unit will do. So it requires a lot of additional wiring. So our engineers are working on that. They have kind of a sheet put together, but there are some hard comparables there that kind of some intangibles that are difficult to put in.
How about the Powerwall, that everyone
Powerwall, that comparable is almost completely done.
Okay.
And I will tell you the biggest difference is for the cost of the Powerwall with one battery, which ironically their batteries are almost the exact same size as ours energy wise. They're a 13, I think they're a 13 and a half kilowatt hour battery. There again, they're using cylindrical cells and they're using NMC instead of lithium iron phosphate. So they are using the lithium that has the cobalt in it. From a political standpoint, I think Elon Musk is moving away from that. In his new cars he's selling outside the United States, he's moving everything to lithium iron phosphate. So I'm sure in the future you'll see that change, because the C stands for the cobalt, which is the conflict mineral that comes out of the Congo and places that are just politically, it's just not a right chemistry to be using if you don't have to. We do use that in like our small LT unit, but that NMC battery is more energy dense. So the physical size of the Powerwall battery is smaller and weighs less than our battery does. So that's about the only negative. Beyond that, you can get 3 of our batteries with an 8K inverter for the price of a Tesla single battery with a 5K inverter.
Excellent.
One of the things that they do well that we're working on for our next iteration is that their battery does allow remote communication and control by either the power grid or Tesla directly. So there are markets now where the power company will come and say, hey, we'll give you a $2,000 rebate on your battery if you give us access to it where we can tap in and draw power out of your battery as we need it. And then they pay you a bonus for that as well. Our battery and inverter don't yet have that communication protocol built in. Tesla does.
Got it.
So there are a few markets where that would matter. But the biggest thing is going to be price. We're going to be at less than half the price of a comparable unit for the battery size. Their system also requires a lot more install expense. They actually run off of a 3-phase 208, which is more of a commercial protocol, versus a split phase 240, which is what your typical residential is, which is what we use. So there are some additional wiring things that have to happen in installing a Tesla system. And the final thing is they do require internet connection, and they require that they have access to your system. So depending on how big brother adverse your customer is, they may or may not like that.
Right.
If the Wi-Fi connection goes down, the internet connection goes down, the Tesla systems will go offline, and they can. They're supposed to have a safeguard in there to stay up, but they're really meant to be controlled by the Tesla mothership, so they can monitor them, gain the information, make tweaks. On the positive side, they can upgrade the firmware. Right? They can make upgrades to it as time goes on. I think the best comparison I can give you there is they're a little bit more Apple, we're a little bit more Android in how we do this. Their system is locked down and controlled by them.
Got it. Good.
Well, I know it's Friday. I don't want to keep you guys.
But if you have any other questions, shoot them to us. We're learning more about this system the more installs we do. It's been a real learning experience for me, just going through the permitting process, getting the building permits to put this in my own home, and learning all the things we didn't know we needed to know. So as you come across questions you can't answer, Greg's probably more available than I am, but we have a team of engineers, and we have several interns now, which are engineering interns, which are really good at helping us get questions answered as they come in. So feel free to shoot us a note.
Will do. In terms of install, so an electrician can install this system. You don't have to be a solar installer per se, but an electrician.
Correct. In fact, I learned that the hard way in mine. So solar installer technically is only doing the roof work, right? Putting the panels on the roof. The system inside your home has to be done by a licensed electrician.
Okay.
So even if you have a solar installation company, the power or the sanctuary itself has to be done by a licensed electrician.
All right. Very good.
when are these gonna be ready to go?
Now,
Right there.
we have 200 batteries and 200 inverters sitting out there going through testing right now. Technically, all 200 of those batteries are sold, but the customers that have bought them can't take them all at once that they have on order. We have another 200 arriving in about 2.5 weeks, and only 120 or 130 of the 200 inverters are pre-sold. So we do have about 70 units right now we could sell in the short term. But then we have another 200 inverters that will be here in about 8 weeks. So our goal is to bring in 200 inverters a month. So now that we're up and rolling, I think we'll be able to do that.
Actually, that's fantastic. I actually have a couple of projects that I'd like to put this on in the placement of because we've already done some of the pricing and the specking on some projects, but now we have project control, and so I would like to see how these look in terms of not comparison, but like Solark was the only one that was available at the time.
Yep.
But the price on these and the capacity doesn't look to be too bad. So, we can, for Colin, we'll probably talk about that and see how we can get that lined up.
All right.
Yeah, just get the order over to Greg. I think right now our ship date is Wednesday, is the next available ship date for one of these. And that's only constrained by how fast we go through testing. We do 100% QC on these. We have an oversized automatic tester that our engineers have designed that we take 16 of these batteries, hook them up, 4 to each one of our testing machines, and they do a complete cycle, all the way full, all the way dead, test all the parameters, test all the BMS, etc. Then they record that in our system by serial number. And so it takes us about 2 to 3 hours per battery to test these. And so we get about 16 of them a day is what we're getting through the testers right now. And so right now with what we have to ship today, Monday and Tuesday, if you gave us an order, then we'd probably be shipping on Wednesday.
Excellent.
Okay.
Good. Any other questions? Greg,
Greg,
I'm looking to see you, Greg.
Greg,
You're on the
Greg's
phone.
gonna come over here. I'll slide over so I'm politically,
Come on.
socially distant.
This is me.
Hey, Greg.
Hey, Greg.
We decided it's Flannel Friday here
Yeah.
because we had a cold front move through. It was 16 degrees when I left my house this morning.
Got you. And we had a hailstorm come through Michigan, and it's 70 degrees.
Oh, wow.
Yeah,
No, it's not 70 here. It's cold.
got you.
Fantastic.
Good. Well, good to see you both. Thank you. Very informative. I think we got more than we expected, and really appreciate the team over there at Lion Energy. Customer service, what I'm hearing is great. What I've experienced, what customers have experienced, just dealing with anything has been fantastic. So
That's all
Thank
Greg.
you.
That's the team that Greg manages. He runs all that. He does a great
that's
job.
been great. I was on the phone with April earlier this week. She was very helpful. So very good. Very happy.
Well, we appreciate you guys. It's been a good partnership so far, and let's just keep growing it.
Let's go.
Yeah.
All right. Take
Hey,
care.
thanks, guys. Have a good weekend.
Have a good weekend too. All right.
We'll see you.
Good meeting you guys. Thanks. Okay. Good work.